Okay, team, this is part of the classwork for Wednesday, September 16th. Depending on how long it takes us to get through this, we might move on to other stuff. So we'll see how long this video is going to be. All right, you need a pen or pencil. You actually don't need your Eureka book for this part of it. However, if you have a notes packet or a notebook, you might want to take some notes. Now I do have the printed notes packet for you. I just haven't gotten it to you yet. But I have posted the digital version on Google Classroom. Okay. I'll probably just title it 916 notes. Okay, so if you want to, you can print it or you can just kind of follow along with the notes. The notes are basically just the slides that we're going to go over today. Okay, so let's do this. We're going to talk about properties of operations. We're actually going to start, because distributive property uses this stuff, we're going to talk about expressions. We're going to talk about like terms, and we're going to talk about rules of exponents. Okay, and then we'll get into the distributing because we have to know that stuff first. Okay. Okay. Oh, quick reminders, drop dead date is the 25th, so next Friday. Parent-teacher conferences are on Thursday. Okay, so let's first talk about the algebraic expression. Now, algebraic expression is basically like the math version of a phrase in language, okay? It combines numbers or variables using different operations. So expressions can use operations like adding, subtracting, multiplying, dividing. You could raise it to some power, any of that kind of stuff, or square root, that kind of thing. Okay, so any operation. Both sides of an equation are expressions, but expressions themselves do not contain equality or inequality signs. What I mean by that, let's say that we have this equation, 2x plus 3 equals 5. Okay. This part right here and this part right here, so both sides of the equal sign but not including the equal sign, that would be an expression by itself. This would be an expression, so this whole group thing right here is an expression. But this all together is not an expression. So to clarify, not an expression as a whole, okay, because it contains an equal sign. So the two sides of the equal sign are expressions, or if we had an inequality sign there, it would be, but not the whole thing together. Okay. Alrighty. Let's talk about this. You might have heard some of these words before. These are basically, I'll write this so you kind of keep track of everything. These are names for the number of terms, and we'll go over what terms mean, or groupings, you could call them, groupings in an expression. So that might be something you want to add to the notes if you printed them, or just write down separately so when you get the printed notes Monday with the Monday pickup, you can add it to it. Okay. So let's talk about terms, and then we'll go over what each of these names are. Okay. Terms, and again, this is probably something you want to write down. Terms, mathematical terms, are numbers and variables that are separated. It's hard to talk and write at the same time fast. That are separated by an addition or subtraction sign. So not multiplying or dividing. Okay. So what I mean by that, if we take a look at these examples, I don't know why I just said that. Okay. This first one, we have -2 times x to the 5th power. So we have a few different operations going on. We have 2 times x, so we've got multiplication, and then we're raising something to a power. But there's no adding or subtracting going on. So that would be considered one term. Now, a one-term expression is called a monomial. Monomial. Okay. Monomial. Kind of an awkward word to say. Monomial. If there are two terms, so in this case we have x raised to the 2nd power, so we're basically multiplying many times, multiplying it by itself, right? And then we have 5, but we're adding 5. So because we have one addition sign, or if it was a subtraction sign, we would count that too. We would call this two terms. So this is one term, this is another term. So the terms are separated by either addition or subtraction signs only. Okay, multiplication doesn't count, division doesn't count, raising it to a power doesn't count, taking the square root doesn't count. It's only addition and subtraction that separate terms. Okay, if there's two terms, it's called binomial. Bi meaning two, binomial. If there's three terms, it's called trinomial, tri meaning three. So we have one term, so 3x, then we have -8, and then we have positive 4x to the 5th. So there's the three terms there. If there's four terms, basically from there we just call it 4-term polynomial or 5-term polynomial or 6-term polynomial. So here we have -7 times a to the 2nd, +9 times b, -4 times b to the 3rd, and then a +6. Sorry, it's kind of blurry. So one thing I want to point out here, you'll notice that I've included the negative sign with these and like the positive, right? So negative there. Always keep the sign that's in front of it. Okay, so with this 4b to the 3rd, there's a minus sign in front of it, so we would consider that a -4b to the 3rd. Okay, when we're just talking about the terms separately. So again, terms are numbers and variables together or not together that are separated only by addition and subtraction signs. Okay. Okay, I think that's all I wanted to go over on that one. Let's move this on over. Okay. Some more vocab, yay! So I'm going to point out several different things, and it kind of already points out stuff for you, so I won't go into too much detail since it already does it for us. But if we were to read this out loud, we would say 3 times x plus y minus 8 plus 2 times y. So you notice there's several operations going on. We have multiplication with the parentheses. We have addition, subtraction, addition. We have multiplication there. Okay, so multiple different operations. So those signs we call operators. We're subtracting, we're adding, we're multiplying. That one's kind of like an invisible one. Same with the parentheses, an invisible one. So those are what we call operators. We won't really talk about that word too much, but I wanted to point it out. Terms. There's several terms in this. We have, remember, terms are separated by subtraction or addition signs. So 2y would be a term, -8 would be a term. Now here's the tricky one. We have y plus x, but we also have that 3, right? So this whole thing could be considered a term, and you can also say that x and y are separate terms. Okay, so there's our terms there. Okay, the whole entire thing together is what we call an algebraic expression. Now you could also separate parts of it and say that those are expressions too, and that's true. Okay. Let's see. There's actually one word that they don't have on here that I do want to add. Actually, let's go over this one first. If there's a number by itself, so no variables with it, you're not multiplying it by a variable in some way. If it's just a number by itself, that's what we call constant. So it's a number all alone. It can be positive, it can be negative, but it's by itself. So that's what we call constant. The other term that I wanted to add is called, ooh, that does not look good. Sorry. Okay. It's called a coefficient. Coefficient. I'm actually surprised it's not on here. Thinking maybe I just missed it, but it's not. Okay, so let's say we have the term 2 times y, since that's in there. If you have a number multiplied by some variable. Okay, so it's being multiplied by some variable or divided by some variable, we could say. That number, the number is called the coefficient. So if we're given the term 2y, 2 would be the coefficient. It's basically just a fancy word for saying the number in front of the variable. Okay, but I will mention that a lot, so that's a good thing to write down. Okay, grouping symbols. Grouping symbols, basically any parentheses. Let me get rid of some of this extra stuff here. Basically any like parentheses or types of parentheses. So if you have like brackets, okay, or those curly Q brackets, okay, those are all called grouping symbols. Okay. I erased some of that. Okay. Generally, if you have, not generally, always, if you have a number or a variable right outside the grouping, so like this 3 here, it means you need to multiply it. Okay. Just like having numbers right next to each other, right? That would mean 3 times 4. Okay, so same thing there. It means multiply. Okay, so let's look at the examples of algebraic expressions. Talking too fast. Okay. I just want to point out the different kinds of terms we have here that we went over on the last slide, the monomial, binomial, trinomial, and just polynomial. Actually, I don't think I mentioned this, but polynomial, I promise I can spell. Okay, polynomial. Polynomial is just the word meaning that there are many terms, basically. There's multiple terms, okay? That's what polynomial means. So you could actually refer to binomials, the ones with 2, as polynomials because they have multiple, okay? It's kind of like a group all thing, an umbrella term. Okay, back to where I was going with this. Okay, 6 would be an algebraic expression. It's all by itself. We would also call it a constant because it's all by itself, right? And if we were referring to it in terms of the number of groupings or expressions, we would call it a monomial because there's only one term. Okay. 6 plus 6. Both 6s here they would both be considered constants because they're all by themselves. Okay. Since there's two of them and they're separated by an addition sign, we would call it a binomial. Binomial. Okay. I'm not struggling, you're struggling. Okay. Here, we have 6 times x to the second power. So 6 right here is going to be a coefficient because it's the number that's being multiplied by some variable. We would call x our variable. Okay, the whole thing is an expression, yes, but we would call it a monomial. Kind of hard to see on blue. It's a monomial expression because there's only one term, right? There's nothing separating it by addition or subtraction. Okay, next one. 6 times x plus 6. So a few things going on here. We have the constant of 6 because it's by itself. We have the coefficient of 6 because it's being multiplied by the variable x. The reason I'm pointing this stuff out is because a lot of times we'll refer to constant or coefficient when we're talking about stuff, so you kind of need to know what's what here. So that's why I'm going over this. If you're totally fine with it, you can, I should have said this before, but you can skip ahead. But this is really important stuff, so I wouldn't if I were you. In fact, I would probably write all this stuff down just so you can look back at it later if we have any questions on it. Okay. Where was I? Oh, yes. These terms, so there's a term, there's a term. They're separated by an addition sign, so we would call it, since there's 2 terms, we'd call it a binomial. It's supposed to be an I. Binomial. Okay, the last one. Take a look at this last one. All 3 of these are constants because they are not being multiplied or divided by some variable. Okay, they're numbers by themselves. They are all separated. One is separated by an addition sign, the other by a subtraction sign. So we would say that each of these 3 are separate terms. And because there's 3 of them, we would call it a trinomial. The ones that you'll hear the most probably this year will be binomial and monomial, right? The single and the double expression. Okay, hopefully that helps kind of clarify what's happening in these expressions and what the terms are called. But if you have questions on them, please let me know. Okay. Ignore that thing on top there. Okay, so let's talk about like terms. You're going to hear the phrase like terms a lot. Okay. I keep saying K, and the more I think about it, I feel like the more I say it. But I'm trying not to. Maybe I need like a rubber band or someone to poke me every time I say it. Anyway, like terms. Like terms are terms that have the same variable and they're raised to the same power. Okay, I just said it again. What's important about knowing what like terms are and what terms are not like terms is because when we have operations like this, where we're maybe adding, or maybe we have one that's actually multiplying, okay, you can do certain operations, but can't do others with unlike terms. What I mean by that is if you have unlike terms, you cannot add or subtract them. You can't. It's impossible. They're not the same, so you cannot combine them. It's like saying, well, let's mash together a pumpkin and hang on, I gotta draw my creepy jack-o'-lantern. Okay. Pumpkin and a stocking for the holiday season, right? You can't combine them. They're not the same holiday. We can't combine them. It's not possible. If you do it, you're gonna be cursed. I don't know. You just can't do it, okay? They're not the same thing, so we can't combine them. Okay. However, if we multiply or divide, you can. So we cannot add or subtract unlike terms, but if you're multiplying or dividing, you can combine them. Okay, so adding and subtracting, you can't. Multiplying and dividing, you can. Burn that into your brains. Okay. All right. What is happening? Okay. Don't clear the canvas. Ah, that was almost bad. So if we look at this expression over here, we can say we're asked to simplify it. Basically simplify, I'm gonna actually write this down. Simplify means to combine any like terms you can. Okay, so to simplify, we would need to find the like terms. So what I like to do and kind of start you guys off doing and getting in the habit of, just so you can recognize things, is circling or underlining or putting different signs next to the like terms. So for example, here we have, notice same variable. So we were looking for x and it's raised to the second power. So we need to find any other terms that have x raised to the second power. Okay, can't be a different variable. It can't be x squared times y. It has to be just x squared, but it can be multiplied by any constant, or sorry, any coefficient. Okay. So here, for example, we have x squared again, and there's no other x squared there. So we could, if we wanted to, take this extra step for combining like terms. We can rearrange, right? Commutative property, we haven't talked about it too much, but commutative property says we can rearrange if we're adding and subtracting. I know will give us the same answer. So we could start by rewriting this and say negative 5x squared minus 2x squared. The next pair, let's see, we have x to the first power. So we're looking for any other term that has x to the first power, including just x. Okay. So those we could rearrange with our expression. So we have positive 5x, negative 8x, and negative x. And the last grouping are our constants, the constants. So we have plus 11 minus 15. Running out of space. Okay. So from there, it's a lot more simple to simplify, right? Because we know our like terms, we can just combine those, the rest stays the same. Again, you don't necessarily have to take this extra step here of rearranging so they're next to each other. If you can keep it all straight in your head and just know that you combine these, you combine those, you combine those, okay, that's totally fine. The extra step just kind of helps when you're first starting off with this type of thing. Okay, so if we were asked to simplify, we now have our like terms together and we can simplify. So let's do it together. We have negative 5x squared minus 2x squared. Now we can add or subtract like terms. Okay, to do that, basically you're going to take your coefficients and do whatever the operation is. So we have negative 5 minus 2. So negative 5 minus 2 would be negative 7. And then you'll basically just drop that down next to it. Okay, so basically we're saying we have negative 5 of something squared, some quantity, and negative 2 of some quantity. because they're like terms, we can combine them. So it's like the jack-o'-lanterns and jack-o'-lanterns, we can combine those. I don't know why I thought of that example. It doesn't really work, but it's fine. You guys know what I'm talking about. Okay, the next part, here we go. We have plus 5x minus 8x minus x. Remember that minus x has the invisible 1 in front of it, so keep that in mind. So let's combine these. Again, you'll take the coefficient, so the numbers there, and do the operation before it. So we have a positive 5 minus 8, so that'd give us negative 3, minus 1. Remember, that's negative 1x. So minus 1. Negative 3 minus 1 would give us negative 4. And again, we just plop that x right down. Because again, we're saying we have 5 of some quantity, negative 8 of some quantity, and negative 1 of some quantity. So put them all together and we've got negative 4 of some quantity, meaning x. Okay, we're almost done here. Then we have 11 minus 15. 11 minus 15. I lost my train of thought for a sec. If we combine those, we get negative 4. And voila, we have simplified. Okay, that one took longer than I was expecting, but that's fine. We're going to move on to exponents for a minute, and then you're going to do some practicing. Basic exponents. Basic exponents. I actually need to pause this for 1 second. Hold on. Hold that thought. Hold that happy thought, Peter. Okay, we're back to it. Exponents. Let's talk about exponents. Whew. You might need to write down quite a few notes on this one. I did print or will print a lot of these for you, but the stuff that I add on to these slides, you might want to write down. I'm going to give myself more room. Okay. All right, basic exponents. Let's talk about them. The number that we're raising to some power, we call that the base. The exponent is what we're raising it to. And what that actually means is we're multiplying a by itself that many times. So if it was a to the third, it would be a times a times a. Okay, so that's what that means. So some basic things to kind of refresh your memory on exponents. Now we get to the slightly more hairy things with exponents. With exponents, this is one of the reasons we talked about like terms. Let me write exponents. Exponents. I can block that off. Okay. With exponents, you cannot add or subtract unlike powers. What I mean by that is if you have x to the second plus x to the third, it's the same variable, but the powers are different, you cannot combine those. Remember, like terms need to be the same variable raised to the same power, so you cannot add or subtract them. However, you can multiply or divide them. And we're going to kind of delve into that. So I'm going to go over a couple different examples just to kind of get you to understand the reasoning behind that, okay? So if we have 3 to the second power, that's the same as saying 3 times 3, which is equal to 9. Okay, go with me here. 3 to the third power would be 3 times 3 times 3, which would be equal to 27. Now, if I were to say 3 to the second plus 3 to the third, we would not be able to add those together, meaning adding the exponents together. So here we go. Let's just lay this out. 3 times 3 is 3 squared plus 3 times 3 times 3 would be the 3 to the third. 3 times 3 we know is 9 plus 27 gives us 36. Okay, go with me. If we were to say 3 to the fifth power, which would be 2 plus 3 here, That'd be like saying 3 times 3 times 3 times 3 times 3, which is 243. So these are not the same. Okay. So when we're adding things, the reason why we cannot add or subtract unlike powers is because they won't equal the same thing. Okay. This right here, 3 to the second plus 3 to the third, is not the same. It will not give you the same answer as 3 to the fifth. Okay. Hopefully that makes sense and didn't confuse you too much, but I wanted to explain kind of the reasoning behind it, behind these weird rules. Okay. All right. So I have these kind of on a cheat sheet for you. So that's why it looks a little different here. But let's go over them. The product rule. So if we're multiplying like variables, but the exponents are not the same, that's fine. When we're multiplying exponents with the same base, we basically just need to add the exponents together, right? So it's the same as that example we just did, okay? Because if we had 3 times 3, which is 3 squared, times 3 times 3 times 3, that would give us 243, which is the same thing as 3 to the fifth. So if we're multiplying and we have the same base, so the same variable, you add the exponent. So if we have a to the m times a to the n, you would have a to the m plus n. Getting tongue twisted there. And I'll go over some examples of this. But quotient rule, basically same thing, but instead of adding the exponents, we would subtract them. So I know it's kind of confusing, but if we're multiplying, we add the exponents. And if we're dividing, we subtract them. Okay. The other ones are just kind of basic ones. So the zero rule basically is just saying that any number, literally any number raised to the 0th power is equal to 1. And I'm not going to go over why that is right now, but maybe some other time. Okay, so literally any number raised to the 0th power is 1. The one rules, basically we're just saying any number raised to the first power is just itself, right? Because b to the second would be b times b. So we're taking off one of those b's. Hopefully that makes sense. And then the other b rule is that 1 raised to literally any power is going to be 1, because 1 times anything, 1 times anything is, or 1 times itself, not anything, 1 times itself is always equal to 1, no matter how many times you multiply it. Power to a power, you won't really see this very much in this class, but I wanted to mention it just in case you were curious. If you have some variable raised to some power, and outside of that, you have that whole thing raised to another power. So x to the fifth raised to the second power. So basically that's like saying x times x times x times x times x, all raised to the second power. Okay. It's basically the same thing as multiplying those two numbers. Okay, so it'd be equal to x to the 10th. Why that is? Good question. If you take x times x times x times x times x and we square it, it's basically like saying this whole thing times itself. So we could get rid of that and then multiply it by itself. And how many x's do you see there? 10. So it's x to the 10th. Okay, I think I went over all I wanted to go over with that one. Yep. Wait, there's one more. No, there's not. Okay. Basically, now you're going to have some practice problems, and I'm going to post that. It'll just be called Exponents and Multiplication assignment. For you guys, for my online kids, you can print it and then do the work on that page. I do want you to show your work. And then you can either take a picture of it and email it to me, or, oh, Rufio, it's okay. Or you can do the work on that paper. Sorry. You can do the work on that paper and drop it off Monday with the drop off. Or you can do the same thing, not print the paper, but just show your work on a scrap piece of paper. Okay? I'm going to pause this really quick to get a handle on my dog. Sorry. Hang on. Okay. For the practice, again, I'm going to post it, but I want to go over 3 problems, so you'll have 3 answers. I want to go over 3 problems with you so you know exactly what you're going to do. Okay. The first one, this is problem number 1 on the paper. It's 6 times z to the 4th multiplied by 4z to the 3rd times k to the 2nd. Okay, so we've got 2 terms, or sorry, we call them terms. 2 terms or expressions that we're multiplying together. Okay, so when you combine things like this, when you have coefficients and you have variables and different variables, what you want to do, now maybe write this down. The first thing you're going to do is multiply the coefficients together. Coefficients. So in this case, we have 6 times 4. That gives us 24. Second thing you're going to do is multiply the like, keyword there, like variables, so the variables that are the same. So in this case, we have z to the 4th times z to the 3rd. Now again, when we're multiplying with exponents and they have the same base, so z and z, it's the same thing as saying z to the 4th plus 3. Oh, hold on. Hold that thought. Okay, let's keep going. Where were we? Oh, yes. So z to the 4th times z to the 3rd would be the same as saying z to the 4th plus 3. So 4 plus 3 gives us 7. So it's the same thing as saying z to the 7th. Okay. The last thing I want to point out is any other variables that don't have like a match that you're multiplying it by. So there's no other k's, right? That's the only k. You just leave it. Leave the same. So it's still going to be k to the 2nd. Now we're just going to combine these answers. Okay, so k to the 2nd. That was a weird k. Into 1. Now we're multiplying all of them, so everything's still going to be multiplied by each other. So we're going to have 24 times z to the 7th times k to the 2nd. Okay, and there you go. So those are the steps you want to take. Multiply the coefficients first, then multiply any like variables, and then any other variables that don't have like a match to it that you're multiplying, you just leave them the same. Okay, so there's number 1. I'm going to go over number 8 next. Number 8. So number 8 is 7y times 6y to the negative 2nd. Now we didn't talk about negative exponents, but for this class, really the only thing you need to know is how to multiply things that have the negatives. So again, we're going to follow the same pattern. So first, multiply coefficients. So we have 7 times 6, and we get 42. Then multiply like variables. In this case, we only have one variable. So we have y times y to the negative 2. Now, if you don't see an exponent, it's the same thing as saying y to the first. So remember, when we're multiplying with exponents and they have the same base, it's the same as adding those exponents. So we could say y to the 1 minus 2, or you could say 1 plus negative 2, same thing, which would be equal to y to the negative 1. Okay, and then we're going to combine our answers. 42 times y to the negative 1. And there we go. So that's how you deal with the negatives. It's basically just you're going to subtract with the negatives instead of adding. Okay. Okay. Last one I'm going to go over, and then you can do the rest by yourselves. There's only 14 problems, so I just did 3. You have 11. You have 11 to do. Last one I'm going to go over is number 12. Number 12. Okay. This one has fractions in it. There is one more with fractions in it, so you get to do that one by yourselves. But we have 1 over h to the 5th power times 1 over h to the 2nd power. Sorry, I've got dust or something on my screen. It's driving me crazy. Okay, now you can do this 2 different ways. But the way I'm going to show you is the shorter way. So let's do that. Now remember, when we're multiplying anything with the same base, it's basically we just need to add those exponents. So that expression right here is the same thing as saying 1 over h, because that's our base, to the 5 plus 2. 5 plus 2 is 7, so our answer would be 1 over h to the 7th power. Now we could actually get more simple than that. Okay. If you have something, and we didn't actually go over this, but it's on your cheat sheet. If you have a fraction that's raised to a power like this, it's the same thing as saying 1 to the 7th over h to the 7th. So basically we're distributing that power. Okay. Now 1 to the 7th, we can simplify. 1 to any number raised to any power is just going to be 1. So our final answer then would be 1 over h to the 7th. Now, if h was actually a number, you would calculate that. So if it was like 2, you would do 2 to the 7th power and put that answer there. Okay, but it's just a variable, so I'm going to leave it like that. And there you go. If you have any questions, I'd rewind parts of this, watch it again. You can ask me questions, look at the cheat sheet notes that I'll put on Google Classroom. Okay. I just said K again. Okay. At least that time I said okay instead of K. I'm going to leave it at that because that took a little longer than I was expecting. You still have the practice stuff to do. So that's all you need to do for Wednesday. Thursday and Friday, you don't have homework because it's parent-teacher conferences. And drop dead date is next Friday. So while you don't have any new work, if you have anything missing or you want to raise your grade, I would do those things on Thursday and Friday. Okay. All right. Let me know if you have any questions.